And now they want you to construct a truth table for the following. These could be, I mean, truth tables, depending on what's going on with them, how many different variables are involved, can, get quite involved. So, sometimes some organization, sometimes maybe rewriting some columns along the way might be helpful. I tried to make some of these earlier slides in these presentations for these show you how I kind of organize the material so that hopefully it gives you some ideas about, organization so that you can keep these things all straight. Um, so the only two variables I have in here, and I don't know what they're standing for, are P and Q. So again, all possible outcomes, for truth and false, and then combined together as being represented here. And so I'm going to slowly work my way through this. So I'm going to first look at this to make a column for not P. So basically, this is just me negating that leftmost column. So everywhere P was true, this is going to be false and vice versa. I also see that not Q is part of it. So I'm going to look at this column here and I'm going to negate that to have the negation of that column. Now I want to start figuring out these pieces here. So first I have P or not Q. So I'm looking at these two. And basically for this to be true, only one of the two statements have to be true or both. So when I look at doing this column here, since P and not Q since P is true and not Q is false for the first instance, it's true. They're both true for the second instance, so it's true. They're both false for the third instance, so that's why it's false. And in the fourth instance, P is false, Q is true, so it makes this statement true. Now I'm going to look at not P and Q, or if not P, then Q. So I'm going to look at these two columns here. And I'm going to keep in mind that I am going in this direction. So basically, not P is the hypothesis, Q is the conclusion. So basically, if not P is false, which is what the first two instances are, it's going to automatically be true. In the third instance, not P is true and Q is true, so it makes that premise true. And in the third instance, not P is true, but yet Q is false. That makes that statement a false statement. So now I have the left-hand side and right-hand side of my biconditional. So now I'm going to see when it's going to be true. And again, for it to be true, either both of these, the orange and purple columns have to be both true, or they have to be both false. If it's like one true and one false, then it's a false statement. So when I do this one, there's, in the first instance, it's going to be true. In the second two instances, it's going to be false. It should be noted here that when I look at this, that long statement I have here is basically and logically equivalent to just saying P. So basically, really the only condition I would have to have for this, and we weren't asked to do this or evaluate this in any way, but basically the main deciding factor with this is what P's doing. If P's true, then that statement's going to be true. If P's false, that statement's going to be false. So the Q doesn't really matter as much as being a part of it as a result.